Lesson 10 for ellipses, or the basics of ellipses. Here you have a picture of an ellipse, and you can notice that an ellipse looks like a circle, but it's pulled in some direction, either horizontally or vertically. When you have an ellipse, you're going to have two axes going through the ellipse, and they meet at a 90-degree angle, so they're perpendicular to each other. Here you have your major axis. That's your more important axis. It goes through the more stretched out area of your ellipse. Your minor axis goes in the opposite direction. Here it goes vertically. The ellipse is still stretched a little bit that way, but not as much as it is horizontally. Where your axes intersect your ellipse are vertices. So if you look where your major axis intersects your ellipse, you're going to find what we call your vertices, or each of them are a vertex. Those are more your major vertices, as opposed to the ones where your minor axis intersects the ellipse. We consider those your co-vertices. So you're going to have four vertices where the major axis, you're going to have four vertices. Two of them are going to be co-vertices, two of them are going to be what we consider more primary vertices. Okay, so your primary ones are going to intersect where they're going to be found where where your major axis intersects your ellipse, and your co-vertices are where your minor axis intersects your ellipse. Sorry about that. You're going to have a standard form, and for now we're going to be dealing with ellipses that have a center of 0, 0. If your ellipse has a different center, your equation changes a little bit. So our major axis here is horizontal. When we have a major axis that's horizontal, we use this general form here. X squared over a squared plus y squared over b squared equals 1. And in this case, a should always be greater than b. That is how you know that the ellipse is stretched horizontally as opposed to vertically. This number here under the x should be greater than the number under the y. You'll also notice in the picture that here x is pulled apart more. The distance from the vertex to the second vertex is further than the distance from the co-vertex to the co-vertex. So that number, it's bigger on the horizontal, so it should be going under the x. So you would know that this is going to be a horizontal major axis. So how do you find A and B to put them into your standard form? Well, if you look over here, you have your center of your ellipse. In this case, your center of your ellipse is at 0, 0. So since your center is at 0, 0, it makes your life a lot easier when you are writing your equations. Okay, to find A, it's essentially the distance from your center out to one of your vertices. So from here to here, which is 2. Okay, the other distance you're going to need is from the center up to your minor, or along your minor axis up to your co-vertex. Well, we know this distance here is 1. So we know the distance from the center to the vertex is what we would consider A. So in this case, A equals 2. And the distance from the center to the co-vertex is 1, so that would be considered our B equals 1. So when we're filling in the equation here, x squared stays, we have to put it over a squared, which is 2, plus y squared over 1 squared would equal 1. And then just simplify this a little more so that you're going to have x squared over 4 plus y squared over 1 equals 1. And then this would be the equation of your ellipse. So remember, you have to find A and B in both of these. And to find A and B, it's just essentially the distance from your vertex, from your center out of your vertex in one direction, and then in the in another direction on your minor and major axes. If you have a vertical major axis, it's a little different. Here you'll notice that the ellipse is stretched more so that it's taller as opposed to wider. If you notice, you're going to still have your equation saying x squared first, followed by y squared. But you'll notice the a and the b have switched. In this case, it's a little different where a is not going to necessarily go along with the x anymore, but it's still going to be greater than what B is. So if you look over here, we're going to have our major axis this time is the vertical axis because it's a taller ellipse. Our minor axis is our horizontal axis. We still have a center at 0, 0, which makes our life a lot easier. So when we go to substitute in what a and b is in our equation, a is always going to go with your major axis. It's always the distance from your center all the way up to your vertex or down to your vertex, either way you want to go. So from here to here, it's 2. I could have gone from the center down. That would also give me 2. Either direction isn't going to matter. I could then find B. B is always going to be the distance from your center along your minor axis to one of your co-vertices. So from here to here, my distance is 1. Or I could have taken from the center out to the other co-vertex for a distance of 1. Okay, so A is always going to go with your major axis. So in this case, A is 2. And in the other number that you have, B is going to be the distance for your minor axis, which is 1. So when we substitute those in, we put x squared over 1 squared plus y squared over 2 squared equals 1, which changes to x squared over 1 plus y squared over 4 equals 1. And then that would be the equation. You'll notice that the larger number that goes along with the major axis is under the y, because in this situation our major axis is a vertical axis. If you look at the previous example, you'll notice that the larger number is under the x, and that's because it matches with the x-axis. It's more stretched out along the x-axis. So let's try a couple. So if you notice here, we have an ellipse. What kind of an ellipse is it? Good, it's stretched tall, so we would consider this a vertical ellipse. So if we have a vertical ellipse, remember your larger number should be under your y. So this number here, this question mark, should be bigger than the one under the x. So remember we have x squared over something plus y squared over something equals 1. Now remember that wherever the larger stretch is, that's where your a is going to go. So it goes under the y squared. So your smaller stretch is going to go under your x squared. So now find this distance from your center. In this case it's 0, 0. So we go from the center up, and we have a distance of 3. And since that's your major axis, remember that's going to be your a value. And then find the distance for your minor axis from your center. So go from the center out to your co-vertex, which is 1. And that's going to be your b value. So writing the equation of this vertical ellipse is going to be x squared over 1 squared plus y squared over 3 squared equals 1. And then just rewrite your denominators, so you have x squared over 1 plus y squared over 9, and set it equal to 1. And then that's your final answer. So let's do a few more, and as they come up I'm going to tell you to pause it to try them yourself, and then you'll check your answers. So here's another example. So why don't you try this one? Hit pause. Okay, so now we're going to go over the problem. So here again you have a center at 0, 0, which makes your life a lot easier. So now we need to go through. Is this a horizontal or is this a vertical major axis? You can tell that since it's stretched wide, it's going to be a horizontal major axis. So then underneath the x squared should be your a, and underneath your y squared should be your b. So we have x squared over a squared plus y squared over b squared equals 1. So we got to find the length of A. So we go from the center out to the vertex, which is going to be 4. So in this case, A equals 4. Here, B would equal 2. So we have B equals 2, and then substitute those into your equation. So x squared over 4 squared plus y squared over 2 squared equals 1. Or x squared over 16 plus y squared over 4 equals 1. And those are your numbers. So pause this now and try this problem for yourself. You'll notice that this one is a horizontal ellipse, so you're going to have your major axis underneath your x squared again. Remember, this is where A will go and B will go under your y. Find the distance. From here to here is 3, from here to here is 2, and then rewrite. So you're going to have x squared over 3 squared, which is 9, plus y squared over 2 squared, which is 4, equals 1. Okay, try this one. You'll notice that it's a vertical ellipse, So underneath y should be your A, and underneath x should be your B. So find the distance from the center out to your vertex, which would be 3. Find the distance from your center to your co-vertex, which is 2. So you're going to have x squared over 4 plus y squared over 9 equals 1. Pause it, try this one. Okay, here it looks like it's harder to tell, but if you look at the numbers, you're going to notice that from the center to your vertex on your horizontal is 5, and from the center up to your other vertex is going to be 4. So because this 5 is larger, you have a horizontal ellipse, so that's going to go underneath your x squared, and you're going to have your y squared as your b. So you have x squared over 25 plus y squared over 16 equals 1. So graphing the ellipse below is kind of very similar to what you've been doing. The important thing to look at is where is your major axis versus your minor axis. Since 25 is greater than 9, you know that this is going to be your A and this is going to be your B. So you go over, we're going to, since our form is x squared and just y squared, we know our center is going to be at 0, 0. We then need to say that A equals 25 and B squared equals 9. Excuse me, this is A squared. So in order to find what A is, remember you take the square root of both sides. So you're going to have A equals 5 and here B equals 3. So you're going to go in both directions. It's a horizontal ellipse, so you're going to go to the right 5, 1, 2, 3, 4, 5, and you're going to put your first vertex. You go to the left 5, 1, 2, 3, 4, 5, and you put your other major vertex. And then you're going to use your B equals 3, so you go up 3 because that's your minor axis. And you go down 3 for your other minor axis. And doing your best to draw your ellipse, and I apologize if mine doesn't come out very good too. There we have our ellipse. Okay, why don't you try this one? If you notice here we have a number that's 25 and this is 36, so A squared would equal 36 and B squared would equal 25. Because the A squared is under the Y and the B squared is under the X, that must mean that we have a vertical ellipse. So it's going to be taller than it's going to be wider. So in order to find out what A is, remember you take the square root, so you're going to get 6 and the square root of 25, which is 5. Your center is going to be at 0, 0. You go up 6, 1, 2, 3, 4, 5, 6, and you go down 6. You go to the right 5, and you go to the left 5, and then you connect the dots to make your ellipse as best you can. Hopefully you can do better than I did. Okay, so that's basically the very basics of an ellipse. That's, you know, having the equation and being able to tell, being able to graph it, knowing which way that it's going to go, and also being able to write the equation of an ellipse with a center at 0, 0.